the degree of the numerator and the degree of the denominator of rational functions. The following ideas can be used to determine the behavior of the function. So here, if the degree of the numerator is greater than the degree of the denominator, this means the end of behavior will mirror the polynomial of the resulting equation, like this one. If we have here f of x and we have g of x, okay, f of x is the numerator and g of x is the denominator, and I told you here m is the degree of the f of x and n is the degree of the g of x, and now m is greater than n. This means the degree of numerator is greater than the denominator. This means the limit approach x to infinity, it will be equal infinity. So here, if we need to find the limit of f of x over g of x, and here the degree of f of x is greater than the degree of g of x, that means it's equal infinity, okay? But here, if we have the degree of the numerator is equal the degree of the numerator, like for example, this one here is down. If we have m, it's equal n. Then here we said is the ratio of the leading coefficients of f and g. That's mean what? So here, let's take an example. If I tell you 3x power 2 minus x plus 1 over, let's make it x power 2 minus 4, for example, okay? So here, when I told you find the limit of this function, here you will look to the degree of the up and down. So here the degree in the up is 2 and in the down 2, so we said here we have equal degree. So we can take the coefficient of the x power 2 and the coefficient of x power 2 in the down and make them together, so it will be equal 3 over 1, equal 3. So here, if you need to find the limit of this function, it will be take the coefficient of the highest power in the up and highest power in the down and make them together by fraction, like that. Are you understand that?
Yes.
Okay, and then if we have the degree of the numerator is smaller than the degree of the denominator, like here m is smaller than n, that's meaning the limit of it will be equal 0. So let's take an example here. Yeah, here he told you which has the greater degree, numerator or denominator. So the degree in the numerator here is equal 3 and the degree in the numerator here is equal 2. That means the degree of the numerator is greater than the degree of the numerator, or it's bigger. Therefore, the end of behavior will mirror, and the end behavior of the result quotient of the leading terms. So here, let's draw it. Here, if you notice here, he take x power 3 plus 1 over 4x power 2 plus 5x plus 1, and now he tried to found it. So it can to be equal 0. So here, if we make it, if we change x, for example, by let's set it's 1. Let's set it's 1. So here it will be 1 plus 1 over 4 multiply 1, which is 4, plus 5 multiply 1, which is 5 plus 1. So it's gonna be 2 over 10. So it will be 2 over 10. So when x is 1, the answer of y, it will be 2 over 10. So it will be very closer to 0, but it's not equal to 0. You see? Here, I put it. Here, when it's 1, it's 2 over 10. So if you cut these into 10 equal parts like that, so you will put here that it will be the point. Okay? And when you go and take the one and sorry, it will be here. Yeah, it will be here. And when he take and make it as 2, so it will be, I think, 5 over 10 or something like that. Then we will have a more of points here and so on by the same way here by the negative when we put it -1, -2, and so on, it give me like that. Okay, so it's very closer to 0, but it's impossible even ever never to equal to 0. Okay, and then he joined between them to give you the graph. So here, this meaning the behavior here and the limit of x, it will be negative infinity from the negative part or from the left part, and it will be positive infinity from the right part. Are you understand that?
Yes.
Okay, here we have another question. Here he told you if f of x equals 6x power 2 plus 1 over 3x power 2 minus 2x minus 1. Now here, if you notice, the degree of the numerator is 2 and the degree of the denominator is 2. So here, how we can find that? You can set directly, you will take the coefficient of x power 2, which is x, over the, which is 6, sorry, and the coefficient of 3. So here the coefficient of x bar 2, which is 3 in down, so it will be 2. Okay, so here's the limit of this function, it will be equal to. And how we get that? You can make it multiply 1 over x to the biggest power up and down, which is 2, up and down. Okay, so here when we go and make that, give me, when I make it multiply 1 over x power 2 up and down, focus in the, here you will take 6 x power 2 multiply 1 over x power 2, it give you 6, plus here 1 multiply 1 over x power 2, it will be 1 over x power 2. And here when you take 1 over x power 2 multiply 3 x power 2, it will be 3. Then here multiply 2x, it will be 2 over x, and then multiply 1, it will be minus 1 over x power 2. Now, if you need to find the limit of each one of them, here you put the limit, and here limit, and here limit. Okay, so here 6 and 3, they are constant, so we just write them. 6 over 3, it will be 2. And or you can make it 6 like it, to be mathematical, good. And then here the limit of the 1 over x, or 1 over x power 2, it will be 0. And we take it before. So here 3 will put it the limit of 2 over x, it will be 0, and the limit of 1 over x power 2, all of them it will be 0. So the answer, it will be 6 over 3, and that's give you 2. So here we said the behavior will approach the horizontal symptom that's the equal to the ratio of leading coefficients. Okay, here he give you the answer of this question, the last one. Okay, here we have another one. Here he told you which has a greater degree, numerator. So the degree of the numerator is 1, and the degree of the denominator is 3. So which one is the biggest? The biggest is the denominator. So here the end of behavior will approach a value of 0, because here the numerator is smaller than the denominator, and we said it's equal to 0. Okay, now I think we finished these questions or this lesson, and now we will take an examples about it. Does the numerator or the denominator have the largest degree? Okay, so here, which one is the largest degree, denominator or numerator? Here,
Numerator.
numerator. Why? Numerator has the
Because it's x square.
denominator, you mean denominator, because it's x square. Okay, which one here, numerator or denominator?
Denominator.
Yes, because it's x power 3 and ends up within half x. And here,
Numerator.
numerator, because here it's x power 2 in the numerator, and in the numerator it's x power 7. Okay, here he make a vision for you about the same thing. Okay, here he told you which is bigger here. if we have f of x equal 3x minus 4 over 8x power 3 minus 1. Of course, here's the degree of numerator. It's smaller than the denominator, and we said the degree of the denominator is bigger. Therefore, the end of behavior, it will be equal to 0. Approach a value of 0. Okay, let's take this question. Here W determines the limits at infinity of each of the following function, then determines the equation of the horizontal symmetry, if any. Okay, so here f of x equal x power 3 minus 4x power 2 plus 3x minus 5 over 3x power 3 plus x power 2 plus 3x minus 4. So the first equation here, which will one is the bigger here, is that numerator or denominator?
Both.
What? I
Both.
both, yeah, that means they are equal. Excellent. So here, because they are equal, what we can do to find the limit of it?
اسمه ايه
Yeah.
the mode 5 4 on the calculator
Uh,
factor it.
okay, you can find it by the calculator, or you can use a simple way here, because here we have the same power up and down, so you can take the coefficient of the x power 3 up and down, it just and write it. So
1
here,
over 3.
yeah, it will be 1 over 3. So the coefficient of x power 3 is 1, and the coefficient of x power 3 is down 3. So here the limit, it will be equal 1 over 3. Okay?